Are you ready?
Welcome to Thermo Battle Arena. Today we will start the battle between two metals that have been shaking the world. On the left side there is the silver metal aluminum, the most economical. On the right side there is the gold metal copper, champion of corrosion resistance. Who is the most efficient at cooking? Called the king of chefs in the world.
A calorimeter is a tool for measuring of heat release or absorbed by an object through changes in temperature. And how to determine the specific heat of a calorimeter? Let's check it out.
Let's begin the battle by calculating its heat using a calorimeter. First, determine the mass of the empty calorimeter. The mass of the empty calorimeter is 0.1212 kg. The weight of room temperature water is 0.1 kg. Add 0.1 kg of room temperature water and record the temperature. We got the temperature which is 27 degrees Celsius. Heat another 0.1 kg of water to 60 degrees Celsius. Mix both the water. Pour it into the calorimeter and then stirring the water. The final temperature is 41 degrees Celsius. Move to calorimeter calculation. From the formula earlier, we get the formula to calculate the specific heat, and this is the formula. We obtain data from the previous experiment, namely, mass of hot water is 0.1 kg. Initial temperature of hot water is 60 degrees Celsius. Mass of cold water is 0.1 kg. Initial temperature of cold water is 27 degrees Celsius. Final temperature of the system is 41 degrees Celsius. Specific heat capacity of water is 4200 joule per kilogram degrees Celsius. And mass of calorimeter is 0.1212 kg. Then we enter the data into the specific heat formula that we have obtained, and we get the specific heat value of the calorimeter. The calorimeter specific heat is 1237.6 joule per kilogram degrees Celsius.
Fast, precise, I have the upper hand.
Wait a minute. I have other powers.
Determine what material is the most efficient. Let's prove the result of the heat capacity of each aluminum and copper. Before starting, we will listen to the explanation from scientists on how to determine the heat capacity of aluminum and copper. Let's check this out.
Next, determine the specific heat of copper. Weigh the empty calorimeter and we get the mass of the empty calorimeter is 0.3535 kg. Heat the water. Heat 0.1 kg of water to a temperature of 100 degrees Celsius. Put the copper in the water that has been heated to 100 degrees Celsius. Put 0.11 kg of water with a temperature of 30 degrees Celsius into the calorimeter. Weigh the water and the calorimeter. We get the mass of the water and the calorimeter is 0.4635 kg. Put copper into a calorimeter filled with water and then stir. Measure the temperature of the water and copper using a temperature until we get the final temperature. The final temperature is 79 degrees Celsius. Reuse the previous formula that we have obtained. Enter data into the formula to get the specific heat of copper.
Calculating session specific heat of copper.
The initial temperature of copper is 100 degrees Celsius minus the final temperature, which is 79 degrees Celsius, so that the change in copper temperature is 21 degrees Celsius. And then we also calculating the final temperature of the system, which is 79 degrees minus the initial temperature of water and calorimeter is 30 degrees Celsius, so that the change in temperature of water and calorimeter is 49 degrees Celsius. From experiments and calculations, we get the following data, namely, mass of copper is 0.0824 kilogram. Temperature change of copper is 21 degrees Celsius. Mass of water is 0.11 kilogram. Specific heat of water is 4200 joule per kilogram degree Celsius. Mass of calorimeter is 0.3535 kilogram. Specific heat of calorimeter is 1237.6 joule per kilogram degree Celsius. And temperature change of water and calorimeter is 49 degrees Celsius. And then enter the data into the same formula that we previously used to calculate the specific heat of the calorimeter. Specific heat of copper is 654.35 joule per kilogram degrees Celsius.
And last, determine the specific heat of aluminum with the empty calorimeter, and we get the mass of the empty calorimeter is 0.3535 kilogram. Heat the water. Heat 0.1 kilogram of water to a temperature of 100 degrees Celsius.
Put the aluminum into the boiled water.
Put 0.11 kilogram of water with a temperature of 30 degrees Celsius into the calorimeter. And then weigh the other water and the calorimeter. We get the mass of the other water and the calorimeter is 0.4635 kilogram. Put aluminum into a calorimeter filled with water and then stir. Measure the temperature of the water and aluminum using a thermometer until we get the final temperature. The final temperature is 73 degrees Celsius. Reuse the previous formula that we have obtained. Enter the data into the formula to get the specific heat of the calorimeter and aluminum.
Calculating session specific heat of aluminum.
And then we also calculating the final temperature of the system, which is 73 degrees Celsius minus the initial temperature of water and calorimeter is 30 degrees Celsius, so that the change in temperature of water and calorimeter is 43 degrees Celsius. From experiments and calculations, we get the following data, namely, mass of aluminum is 0.1012 kilogram. Mass of water is 0.11 kilogram. Mass of calorimeter is 0.3535 kilogram. Specific heat of water is 4200 joule per kilogram degree Celsius. Specific heat of calorimeter is 1237.6 joule per kilogram degree Celsius. Temperature change of aluminum is 27 degrees Celsius. Temperature change of water is 43 degrees Celsius, and then temperature change of calorimeter is 43 degrees Celsius. Enter the data into the same formula we previously used to calculate the specific heat of the calorimeter and copper. The specific heat of aluminum is 1447.6 joule per kilogram degree Celsius.
High heat capacity, so the heat lasts longer.
I get hot quickly, but I get cold quickly too. Perfect, precise temperature control. want precision, I'm the answer. Professional chefs choose me.
If you need light, cheap, and practical cooking tools, I'm the best choice.
In terms of heat transfer efficiency, copper is the champion. With its high thermal conductivity, it heats faster and more evenly. However, when it comes to effectiveness in everyday use, aluminum is superior because it is lightweight, cheaper, and still quite good at conducting heat. So, efficient, copper. Effective, aluminum. Choose the cookware material according to your needs. Thanks for watching. See you in the next battle.